Juno sees a lava lake on Io. Voyager-1 isn't spouting nonsense anymore. Titan Dragonfly gets the green light from NASA, and TESS finds its first rogue planet. All this and more in this week's Space Bites. NASA's Juno spacecraft has been making regular flybys of Io over the last half year or so, and for the last two flybys, it came within 1,500 kilometers of the surface of Io. That's close. It's not as close as missions have come in the past, but still very close, and it's current. It's letting geologists see what is the state of all of the volcanoes across the surface of Io. And so NASA released this really cool animation that shows a recreation, a simulation based on the data that they've got for one large lava lake on the surface of Io. The lake is called Loki Patera, and it is 200 kilometers long. And it is just on the surface. There's a big island in the middle of this lake. And so we got this recreation of what it probably looks like based on the data. And so when you look at it, you're seeing like all the way around the crater rim, you're seeing sort of the red spots. And this is where fresh magma is flowing into the region. And yet the surface is glassy smooth. And this is, again, based on this data from Juno. And so they think that it is very similar to obsidian glass, the kind of volcanic glass that we see here on Earth. Really want to see close-up pictures of this. Like, when are we going to get a lander to Io to be able to give us some more information about this? Now, I did a really amazing interview with one of the researchers who is looking at the data coming from Juno, thinking about future missions to Io. So I definitely recommend that you check that out. Voyager-1 isn't spouting nonsense anymore. Good news, everyone. Back in November, NASA's Voyager-1 was sending home garbled data. And, you know, whenever you get some problem with a spacecraft, you can generally assume it's a cosmic ray. Some ion struck the spacecraft in exactly the wrong place, flipped some memory switches, corrupted a piece of equipment, and now NASA had to work around the damage. They were able to figure out that the problem was coming from the flight data subsystem. And this is just one of the computers on board Voyager-1. And a chunk of this computer was now damaged. And so for them to be able to restore communications with Voyager-1, they had to get that subsystem operating on other parts, other computers inside Voyager-1. And the problem was that it was too big to fit in any one specific computer. So they had to reprogram the way the code worked to split it up into multiple pieces and tuck it into other parts of Voyager-1's computer system. They were able to pull this off. They were able to restart the spacecraft, and communications were restored. And so now Voyager-1 is sending home just the normal data that NASA was expecting. And this is amazing, like that this spacecraft that is this old, right, launched in 1977, is still able to communicate with Earth and still send useful data back home. But also, these kinds of old age problems are just going to continue as its power system runs down, as computers and equipment is continually exposed to the hazards of spaceflight. And so prepare yourself emotionally for a time when the Voyagers will no longer be with us. NASA gives the green light for Dragonfly. So last week, I reported on the problems that NASA is having with the Mars sample return mission, how an independent analysis said that the mission is going to be more expensive, it's going to take a lot longer to return those samples, and they're sort of going back to square one and trying to figure out what is the best solution for Mars sample return. But at the same time, they announced that they were going ahead with the Titan Dragonfly. And this is one of the most exciting missions that NASA is working on right now. This is a quadcopter. I guess it's an octocopter. It's got 4 rotors, but each one is double. And it's going to be going to Titan, which is Saturn's largest moon. It has a thick atmosphere filled with hydrocarbons, and it is going to be flying around with a RTG-powered octocopter. Should I explain what an RTG is? A nuclear-powered? Because I hate it. Whenever I say it's a nuclear-powered helicopter, people are like, well, it's not really nuclear-powered. It's actually a radioisotopic thermoelectric generator. I'm like, I know that it is. It's a decaying piece of plutonium. But then if I say it's an RTG, then people don't know what the acronym stands for. So it's going to Titan. What's interesting about this mission is that it also had a smaller budget originally, and the new budget looks like it's going to be about $3.35 billion. It had a shorter timeline, and now it looks like it's not going to launch until about 2028. And then it's going to take forever to get to Titan. But still, one day our future distant descendants will see a nuclear-powered helicopter flying on Titan. And so I guess, like, in some cases, you know, we can see this budget expansion and go, nope, there's absolutely no room for this. The timeline expansion, this is unacceptable. In other cases, just the pure awesomeness of a nuclear-powered helicopter on Titan, just sort of, okay, we understand these things are expensive and they're going to take time, but let's get to Titan. And the goal is to fly around in the atmosphere of Titan, to sample different deposits of organic compounds, to try and understand if we've got the raw chemicals for life on Titan, how is this environment similar to what Earth might have been like in its early history? So Titan Dragonfly moving forward. TESS finds its first rogue planet. NASA's TESS mission has identified thousands of candidate exoplanets, discovered hundreds more, and yet it uses a fairly specific method of finding exoplanets. It uses the transit method. So it's looking at the light of the star, watches as an exoplanet passes in front, measures the change in brightness, and then uses that to figure out, you know, is there an exoplanet there? How big is it? How long does it take to pass in front of the star? But researchers using TESS also theorize that it could find another kind of exoplanet. And that is using a technique called gravitational microlensing. And this is a technique where you've got a star and then a planet, rogue planet, passes directly in between us and that star and causes a slight change in the brightness of the star. And so researchers looked back through all of the TESS data, looking for any of these possible changes in brightness of the star, and they found one that really fits the bill perfectly. They think that it is a rogue planet, a free-floating planet that's just drifting through the Milky Way, and it passed in front of a star about 10 light years away for about 100 minutes. And during that process, gave this strong signal and allowed them to estimate the kind of planet that they saw. So this is sort of like the first step. You could imagine future missions like, say, Nancy Grace Roman, turning up tons and tons more of them. But it's pretty exciting to think that there are these rogue planets just drifting around in the Milky Way, and we can find them. But some bad news about TESS, and that is that the mission is actually in safe mode right now. NASA announced on the 23rd of April that the spacecraft had gone into safe mode. And actually, this is the second time that it did it this month. It went into safe mode earlier this month. They got it back operational again, and then it went into safe mode again. So it's too early. It just happened in the last couple of days, but we will be sort of waiting to find out what the problem is. And hopefully it won't take long and the spacecraft will come back into operation, come out of safe mode. Every week, we do a vote on our channel where you tell us what you thought was the best, most interesting space news. And it was pretty close, but the winner this week was the news that James Webb has found evidence for the first stars in the universe. And I totally agree. So cool. We post this vote on our YouTube channel within about 24 hours of when we post Space Bites. We put it into the community tab. Now, you could just be scrolling on YouTube to see the vote come up, so go ahead and just vote. And of course, the best chance to see it is to be subscribed to the channel, to click on the notifications bell, to have watched a bunch of our videos recently. That gives you the best chance of seeing the vote. And if you do, please tell us what you think. Nancy Grace Roman gets its reaction wheels. Longtime fans of the show know that I'm pretty obsessed with reaction wheels. These are these giant spinning wheels that are inside spacecraft that allow them to change the direction that they're pointing, to maintain a very fixed position while they're making their observations. And some classic mission failures have happened in the past because of the loss of reaction wheels. And when you look at what these reaction wheels really are, you can understand why they are a part of a spacecraft that can go badly. And NASA recently published a video showing the engineers attaching the reaction wheel system to the Nancy Grace Roman telescope. And then they go into detail about how these reaction wheels work. Each one of the 6 reaction wheels on Nancy Grace Roman is almost half a meter across, weighs 20 kilograms, and can spin up to 4,000 revolutions per minute. So these are like giant flywheels spinning inside this spacecraft. And they have to just keep spinning and spinning and spinning and be able to work for years and years and years. And it has 6. It only needs 3, but having all 6 allows it to move a lot more quickly and then gives it redundancy when those reaction wheels inevitably fail. But like 6 is not enough. I want to see a spacecraft with 40 or 50 reaction wheels. Then I might feel safe. But still, like if you ever wanted to see in detail what these things look like and how they work, definitely check out this video. NASA's solar sail goes to space. So this week, a Rocket Lab Electron rocket blasted off and put 2 payloads into space. One was a Korean satellite, and the other was NASA's new solar sail prototype called the Advanced Composite Solar Sail System, or ACS-3. Now, this is designed to test out how well solar sailing works in a low Earth orbit environment. So the rocket blasted off, put the solar sail into about a 1,000 kilometer orbit, which is about double the height of the International Space Station. This is the sweet spot where you're high enough above the atmosphere where it's not going to slow down the solar sail, but you're going to be able to use the light pressure coming from the sun to be able to change your orbit. It then was able to deploy the solar sail. It has these composite fiber booms that extended out from the spacecraft, and the final sail size is about 9 meters on a side. And now it's operational. They were able to deploy the sail, and now it's receiving this direct light pressure coming from the sun, which is the equivalent of holding a paper clip in your hands. Like when you think about the force that's coming down on your hand from that paper clip, that's how much force this solar sail receives, but it's constant and it's free. And so now NASA is going to try to change the orbit of this solar sail with each orbit as it goes around the Earth. And hopefully over time, they'll be able to demonstrate and really understand how well these solar sails are going to work. So we all want more solar sails, but this is another great baby step forward into understanding this technology. 2 mind-blowing videos from Chandra. Now, we think about space as being static. Like the things that we see in our telescopes are these gigantic structures that formed over billions of years. And so although you can perceive them, you're not going to see a lot changing. But other things do change. And so supernova remnants, the exploding debris clouds after a star has detonated, do change over time. And many telescopes have been operating long enough that we can actually start to see these changes over time. So we got 2 time-lapse videos of supernova remnants from the Chandra X-ray Observatory. One is called Cassiopeia A, and the other is the famous Crab Nebula. In the time-lapse, you can see as these structures are moving outward from the center where the star detonated. It's really cool. And I just want to remind you that NASA is going to be canceling the Chandra Observatory. And so we could be seeing the final images of these long time lapses. Is NASA scaling back Artemis III? So I want to direct your attention to some really excellent reporting that's coming out of Ars Technica from Eric Berger, who I think is probably the best space journalist in the game right now. And he's reporting that multiple sources are telling him that we might be seeing a downscaling, a changing of the plans for Artemis III. And this isn't super surprising. I mean, Artemis II is expected to launch in 2025. Artemis III, the one where you get the launch of the Space Launch System, the Orion capsule, it goes to the moon. It meets up with the SpaceX Starship human landing system, which has been launched and refueled in orbit many times and flown out to the moon and already demonstrated, like there's a big to-do list. And it's starting to think that maybe September 2026 human landing on the moon isn't going to come together, maybe? So it's possible that NASA is exploring alternative ideas for how Artemis III might play out. And so one idea is instead maybe scale it back and do a launch of Starship and then have a launch of Orion capsule, and they meet in orbit and test out various docking techniques, the kinds of knowledge that will be required to be able to actually do this in lunar orbit to lead to a landing on the moon. This was very similar to the Apollo 9 mission, so we could see sort of a recreation of the Apollo 9 mission, which makes sense. If Artemis II is a recreation of the Apollo 8 mission, then it makes sense to take that next step. Wow, they sort of had figured this all out back in the 60s. And then another idea is maybe you just have the crew fly to the Lunar Gateway and go on board the Lunar Gateway, you know, spruce it up, unpack, and then come home. And there are a bunch of issues that are sort of starting to put pressure on the timeline. Of course, there's some issues with Orion's heat shield. There is just the level of development with Starship. That thing needs to work. It needs to fly. It needs to refuel. It needs to go to the moon. It needs to test landing on the moon. It needs to be able to go back into lunar orbit. None of these things have been done yet. And we are around 2 years away from humans landing on the moon. And then there are the spacesuits. So they still don't have the spacesuits that the astronauts are going to wear when they get out on the moon. So there's a lot of issues, and they're going to start to cause problems to the timeline. So it does make sense that maybe NASA is going to consider some different plans and maybe push human landing out. But this is all very tentative, and this is reporting from Ars Technica, so we'll keep you posted. I'm going to talk some more about Artemis at the end of this episode, so stay tuned for that. You're watching this video right now, but I recorded it yesterday. So what I'm doing right now is I'm writing my weekly email newsletter. This is a gigantic newsletter that I send out by email every Friday afternoon. It goes out to well over 70,000 people. It's completely free. I write every word and you can subscribe to it. And you want to, because if you're interested in space news, we have a ton more news in the newsletter that we just don't have time to talk about here on Space Bites. For example, the news that there was a doomed comet near the sun during the eclipse that many amateur astronomers saw. Ingenuity sent its final data back home, and now it's official. Ingenuity is over. And why we should put a gravitational wave observatory on the moon. So if you want to check out those stories, as well as everything else we're working at Universe Today, go to universetoday.com/newsletter. I want to talk more about Artemis and a capabilities-driven approach to space exploration. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Dennis Alberti, Dougie Stewart, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Mark Anstis, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. When I see the possible news of slipping timelines and all of the issues associated with trying to accomplish this amazing goal of putting humans on the moon, I think about alternative histories, counterfactuals, what could have been, you know, for all mankind type stories. And so the one that really powerfully resonates with me is back in 2014. This was sort of this weird time where NASA really wasn't sure where it was going to go. Were they going to go back to the moon? Were they going to try to explore an asteroid? Were they going to go to Mars? There was a lot of ideas, but there was no firm goal. And of course, after 2016, we got that decision from the Trump administration. No, they're going to return to the moon. It's everything locked in to that goal. And we're still seeing as they're working towards putting humans on the moon, not by 2024, maybe by 2026, maybe later. But there was this alternative strategy that was presented back in 2014 that I really like, and it's called a capabilities-driven framework. I know, very boring name, but what it is that instead of necessarily picking some giant goal that then will get changed as the various administrations come and go and people decide, oh, we don't want to go to the moon. Oh, going to Mars would look really good for politics reasons. No, let's just increase the overall capability of human space exploration that can then go to any goal. And sort of the classic example, this was back in the Gemini program, when there was just this giant laundry list of things that needed to be done for space exploration. Going on spacewalks, docking spacecraft together, changing orbital altitudes, and all of the bits and pieces that would later come together for being able to go to the moon. And really, I know a lot of people feel like space exploration has stalled. We got people at the International Space Station just going around the Earth again and again and again. We got decades of the space shuttle, which was cool, but it didn't really feel like things were moving forward. And so with the capabilities-driven framework, you just have this giant list of additional capabilities that you want to bring on board. The ability to fly at higher orbits, the ability to last longer in deep space, the ability to dock spacecraft together, the ability to refuel, resupply, in situ resource utilization, and so on and so forth, without necessarily any specific goal. And so if an administration changes, you just keep going, you just keep adding, and each new mission takes one more step. And after a while, things that seemed like big, audacious goals, like landing humans on the moon, are well within the capability of what you are able to do as an agency. And so there's some documents we'll put some links into. You can go and check out this sort of this alternative history of what could have been, the one that I really like, but I understand we're in the one that we're in. So anyway, I really like capabilities-driven frameworks. We'll see you next week.